Now we're going to take a look at the Arduino side of things for this PicoVoice project. As I mentioned in the configuring the PicoVoice commands in Rhino in their online web service, you need to have the unique identifier for the board in order to download the correct model for your board. So of course you have to have your board set up first. That my recommendation is follow their instructions that they have on their site. They have actually very good documentation. You'll want to install the board for the Arduino Nano, and this is the Nano 33BLE, not the old Nano. And it'll be under Arduino Embed OS Nano boards once it's installed. So get that piece of hardware installed. Also install the library for PicoVoice. Again, follow their instructions. It's part of the built-in Arduino library manager, so you should be able to just search it and install it. It's pretty straightforward. So once you've done that, one of the first things you should do once you've plugged in a board, tested, make sure it's connected, just make sure that you could see it on the COM port, and if you want to, you can get the board info, which is more or less useless. The first thing you're going to want to do is open up the PicoVoice examples and go and find the Get UUID program. This is a program you're going to temporarily load onto the board that will get you the unique identifier. Now, this is the unique identifier of the Bluetooth device that's on the board. This is, if you're a networking person, this is like your MAC address. It's a unique identifier for this device. It allows other devices to identify this board as a unique Bluetooth device. In this case, they're using it for licensing purposes. So what you do is open up the example file, install it, upload it onto the board, and when you open up a serial monitor, it will present you with the UUID, which is this hex string right here. So copy that out, paste it, and save it, and keep track of what board uses what ID. Again, this is a unique identifier, so for each board it's going to have a separate UUID. Once you have that number, you could go into the Rhino and create the model and actually download the model. That's the step in the other video where I say you put in the UUID. Well, that's where you put it. Once you've got that, you can download the model, and now you can actually start programming on the Arduino side. They have a example called PicoVoice example that is a really good place to start, and this is where my core code pulls from too. Let's walk through this real quick. They have two includes. One is the include for the PicoVoice, which is the library, and then they have the parameter file. Then parameter file, as we saw previously, this is that hex file that contains all of the magic to convert your voice into some sort of command. So this is what gets downloaded off of their site. They define memory size. This is critical, the access key. This is where you're going to replace this with your actual access key that you receive from PicoVoice. This is when you first create your account. It says, please do not share this, etc. The code will not run without an access key. So keep that in mind. They do some more setup settings, which I have not messed with very much at all. Then toward the top of the file, and I'm going to skip by these for now, there are two callbacks, a wake word callback and an inference callback. But before that code would be hit, you would hit setup. And this is pretty much copy and paste that I copy and paste into my code, where it says what's the status, did it do a connection, creates the PicoVoice instance. If it doesn't, it will tell you that it failed. It tells you what it is. It prints the wake word, things like that. So this is going to be common toward any application you're building with PicoVoice. I put this into a method that just handles. I have like a called setup PicoVoice that runs through all this. Their debugging is pretty good. So if it does fail on startup, it does print some pretty good information into the serial debug window. That's key for if you have licensing problems. If it doesn't recognize you've got the wrong UUID for the parm file, it'll say that in there. If you've got the wrong access key, it will say that also. So they do a good feedback with that. So that's the startup, and then you'd have whatever other startup stuff you have in your code. Then there is the ongoing loop, and this is what's looping and listening and making sure that PicoVoice is still running. Again, this is a copy and paste job that I would put into my code, and runs. If for some reason it fails, it will dump a failure notice onto the serial print. Now, so how does it actually handle the voice stuff? Well, it handles it through the callbacks. So the callback, the main code will, when it's triggered, it will call one of these callbacks. So in this case, when it notices the wake word, so there's a wake word callback, and when it notices the wake word, it's going to print a serial wake word detected. Now, this is where you can add additional code to say, turn on an LED so that the user knows that it's listening. Maybe make a tone or a beep or something to let the user know that it's listening. So you could add additional code under this callback to handle it. So this is going to get called anytime the wake word is heard. So if you say PicoVoice, this code will get called. PicoVoice, 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 it'll get called. The inference callback, this is where the magic is for processing the commands. So this will get called automatically when PicoVoice picks up voice commands. And it has a couple of things that you want to pay attention to. One is inference is understood. If the word has been understood, in other words, it's part of the dictionary, it's part of the model that you have created, this will be true. Otherwise, it's false. So this tells you, hey, I did understand what they just said. Underneath that is the intent. And the intent is, okay, I understood what you said, and here's what I think you said. So this is bed up, bed down, or whatever you've programmed in your model. Now there's another layer deep, which I do not currently use, but you can certainly use, and that is their idea of slots. Underneath an intent, you can have sub commands or more detailed commands. This would be used in a situation such as turn on lights. That would be a simple intent. Turn on lights blue, lights green, lights red. The blue, green, and red would be the slots. They use very often a coffee machine example. Brew full pot, brew half pot, brew quarter pot. The amount, the quantity is what they're throwing into slots. Now, in the particular use case I'm working on right now, I don't need that. My commands are far simpler. It's bed up more, very straightforward. So I don't even have to touch that. So if it did recognize it, it will print out for a given slot what its value was. So it would be intent would be light, slot would be color, value would be blue. So in their sample code, it just prints all this stuff out in the serial print line. And now you actually want to do something about it, and which I will show you that in the next video. Once all of this is done, you delete the inference to basically clear it and flush it. Helpful hint, make sure this is at the end. If you put this too early up, you're going to lose the contents of this object, and then you won't be able to work it, and you'll have bugs, which is what I learned from the School of Hard Knocks. Long story short, you want to do the delete. Make sure it's at the end once you're done working with the object. So that is the basic program that they include, the PicoVoice example that you should start with. Start with that, and I will be showing you a little more detail about how I implement it for my particular use case of controlling a hospital bed in the next video.